As Claudine Sierra once said, water used to be fresh, pure, and drinkable. Now water has lots of fecal matter and bacteria.
Indeed.
Ladies and gentlemen, my name is Sen Saidi,
And mine is Sensei. We're genius from Believe International School, Maputo, Mozambique.
and what brings us here today is the effect of fertilizers on the quality of creek over time. It is known that many people use fertilizers for commercial use, but are unaware of its harmful impacts. The main two ingredients in fertilizers are nitrogen and phosphorus, which are present in fertilizers through compounds such as ammonium phosphate and nitrate. The excess nitrates are as dangerous as high nitrate levels in drinking water can cause infants to develop illnesses such as methemoglobinemia, a disorder which interferes with oxygen intake in the circulatory system. And in this experiment, we studied the effect of fertilizers on water quality from Maputo Creek over time. So Hassan, enlighten us.
Many people use fertilizer in their farms and backyards to increase the crop yield or enhance the growth of their plants. However, the improper use of fertilizer combined with runoff can contaminate the groundwater of creeks and degrade the water quality. Nutrients in fertilizer could cause nutrient buildups in streams, lakes, and water, and rivers, stimulating the unwanted growth of algae and other aquatic plants. Furthermore, the nutrient enrichment could lead to reduced dissolved oxygen concentrations. Without sufficient dissolved oxygen concentrations, fish and other aquatic plants could suffocate. Henderson said, fertilizer is primarily made up of two nutrients, such as nitrogen and phosphorus. Phosphorus is mainly responsible for algal blooms in surface water and can cause an excessive amount of nutrients. Its low solubility renders the loss of phosphate in water insignificant, especially in comparison to quantities released by industrial waste. On the other hand, nitrogen is highly soluble and can reach down through soil, contaminating the groundwater.
We hypothesized that as the amount of fertilizers in Maputo Creek decreased, the water quality from Maputo Creek would decrease. The drastic increase in TDS nitrate levels and overall decrease in TD and pH after fertilizer was added supported our hypothesis. After fertilizer was added, pH and TDS exceeded the US guidelines of 500 parts per million and 10 parts per million respectively, while the pH dropped the acceptable range of 6.5 to 8.5 listed in the secondary maximum contaminant level for pH. Over a period of 4 days, TDS levels for all treatments increased, with the given samples 1.5 surpassing 9,990 parts per million on the 4th day, as it is shown in figure 2a. TDS is the total concentration of dissolved ions. Therefore, it makes sense that TDS would increase after soluble fertilizers dissolved into the water, which adds thousands of ions. The experiment concluded after 4 days, but we believe that TDS would have continued to climb if measured for a long duration, highlighting the negative impact that fertilizer has on water quality.
Data was collected by measuring the change in TDS, pH, and nitrate levels of water from Maputo Creek over a period of 4 days after the addition of 3 different fertilizer treatments. Each treatment was applied to 2 samples, and there were 2 samples that were not given fertilizer and added as control samples. As expected, the control samples added water solution remained at approximately the same level as the nitrate concentrations, staying constant at 0 parts per million, while the TDS and pH level were slightly increasing. Bar graphs and ANOVA tests were used to compare the effect of fertilizer dosage on concentrations of TDS, pH, and nitrate levels shown in figure 1a, 1b, and 1c. The ANOVA test demonstrated that fertilizer had a significant effect on all three indicators. Then, the linear regression also confirmed that they had a strong relationship between time and TDS, shown in figure 2a, and table 1. Moreover, in the fourth day, there were no values recorded because it had exceeded the maximum value of 9,990 parts per million in the TDS meter. And back then, on the second day, the nitrate levels had spiked, and all 3 indicators had increased by 10 parts per million, and gradually returned to the original forms, as is shown in the figure C. Then let's pass to the methods. With regard to the sample collection, 812OZ water samples were stored in our house at room temperature over a period of 4 days to study the effect of fertilizers on water quality. The measuring cups helped ensure that an equal amount of water creek was in each of the jars. The jars were then taken to the house and labeled.
The TDS, pH, and nitrogen levels of water in each of the jars were measured using a TDS meter, pH meter, and nutrient strips, respectively.
Regarding the fertilizer distribution, three different fertilizer treatments will be applied to 6 jars. Each treatment of 0.5 TSP, 1 TSP, and 1.5 TSP has to replicate and result in a fertilizer concentrations.
In order to determine the fertilizer's effect on water quality of creek over time, TDS, pH, and nitrogen levels were recorded in a Google spreadsheet. We used linear regression on a scatter plot to display the relative values to study the impact the time had on individual treatments.
As a result, it reveals that continual use of fertilizer degrades the water quality, rendering it dangerous for aquatic species and for human consumption. Therefore, we suggested that we should limit the continual use of fertilizer and protect the environment and their peers. Thank you for the attention.